So you want to have your books open to page 627. We're going to be working through lesson number 3. What I want you to start out with is box in solving systems. That's what this entire unit is on, is solving systems. And there are 3 different ways that we could solve systems. So the first way was the first lesson of this unit, and it was graphing. You'll always get 2 systems, and one of the methods to solve is you could put it into your calculator, and then how that would be solved is the solution to the 2 systems. So that right there, that would be the solution where the 2 systems intersect. The second method is what we're going to do today, and it's a method called substitution. And then the third method is what we will do tomorrow, and it's a method called elimination. What's going to happen is eventually you're just going to be given 2 systems and asked the solution, and you'll be able to pick which method you like the best, whether it's graphing, whether it's substitution, or whether it's elimination. But the only thing I have got to sort of warn you about is on the quiz, which will be on Monday, because I need to test all 3 of these concepts, there will be a graphing question, then there will be a substitution question, and then I will say solve this by elimination. But if it's an exam and it's multiple choice questions or numeric response, you pick what you prefer. And everybody here will have a favorite. And I'll ask you what they are tomorrow, whether it's substitution or elimination. Everybody likes graphing too. Okay, you don't have a lot of room up here, but I want you to write, we're going to do an example up here because we need a few more examples than the book gives. So remember that we're solving by, it's something called substitution. So I want you to write y is equal to 2x plus 10. And then the second system that I will give you is 2x plus y is equal to negative 2. We need to find what the x and the y coordinate are. I could graph this, right? I already know what this y is equal to. I could solve for this y in one step. I could graph it, but here's how you do substitution. If I look at this first system, it has y solved for me, right? I know what y is. Y is 2x plus 10. If I look at my second system, I have a y here. So what I'm going to do is I'm going to box in this y. This is what y is equal to. Or sorry, there's y. So you take this 2x plus 10 and you substitute it into the second system. So what would happen if you do that is you would have 2x, then you'd have plus, you would take out your y and put in what y is. So y is at 2x plus 10. And then you'd say that is equal to negative 2. Now, get rid of the brackets, and you're going to see that you actually solved one of your variables. So let's get rid of the brackets. There's an invisible 1 in front of that bracket, so I'm going to bring down the 2x, and then it's going to be plus 2x plus 10 is equal to negative 2. You're going to have like terms with these questions, so that is going to be 4x's plus 10 is equal to negative 2. Which variable am I solving for right now? It's going to be x, right? The point of substitution that you'll see, and it takes a few examples before you start seeing it, is we substitute because then we're only going to have one variable to contend with. So I need to solve this x. So I'm going to subtract 10 from both sides. And I'm going to have 4x is equal to negative 12. And then I'm going to divide by 4. And I have what x is equal to. X is equal to negative 3. So once you have your x variable or one of your variables solved, I now need my other variable, which is y. So what I would do is I know that x is -3. I'm going to go and look at the two systems. And you guys, this first system here, look at how it's written. Y is equal to, if I put my -3 in there, because that's what x is, I know what y is, right? Y is equal to this. So let's figure out what y would be. Y is equal to 2, x was -3 plus 10. Y is equal to, that would be -6 plus 10, and y is equal to 4. So x was equal to -3, and y is equal to 4. I'm just going to write that down here. Okay, let's look at this first class example. What you do is you look at your two systems. One of these systems, I could solve for one of the variables in one step. I either want x is equal to or y is equal to. Only one of these I could solve in one step. Do you know which variable it is? What would it be? It's actually not the y. That would be 2 steps. It would be this one. In one step, you guys, I could get what x is equal to. How I would do that is I would minus 4y and I would minus 4y. In one step, I just found what x is equal to. X is equal to 17 minus 4y. As soon as you do that, as soon as you have x is equal to or y is equal to, you say, okay, I just found this variable. I found x, right? This is what x is equal to, 17 minus 4y. You then look at your other system and you say, where is x? Because I could take the x out and put in 17 minus 4y. So the x is right here. So that x would come out. So it's going to be 2, x comes out, 17 minus 4y goes in. And then write everything else down. Carly, make sure you're getting this. Minus y is equal to 7. Get rid of your brackets. So get that 2 distributed inside. You're going to have 34 minus 8y minus, this guy's 1y, it's equal to 7. You'll join, there's always going to be like terms that you could join together. In this example, it's the y's. So it's going to be 34, and then -8 minus 1, that gives you -9y's, and that's equal to 7. And I'm going to solve for y now. Now there's two different ways I could solve for y, right? I could subtract 34 from both sides, or I could make my y positive. What I'm actually going to do is I'm going to do the opposite of what you're used to. I'm going to keep my y here, and I'm going to get rid of the 34, just to show you that there's two different methods that you could do. Then you would have -9y is equal to 7 minus 34, which is -27. How do I isolate y? Divide by -9. And now I have y is equal to two negatives will give you a positive, and my y is 3. You now need x. If you've solved for y, you've solved for half, right? What is your x value going to be? So you look up here. Do you see where you would plug in 3? Do you guys see where it would be that you would get the x value? Where would it be? That's right, right here. I put it right here because this is what x is equal to. So you guys, if I know that y is 3, right, I know as y is 3, I could put it right there. And then I will have what x is equal to. X is equal to 17 minus 4 times 3. So x is equal to 17 minus 4 times 3. and x is 5. Let's say you didn't see where Carly said to put the x, or sorry, to put the y. Let's say you didn't see that you forgot that you had solved for x here. You could have actually put your y is 3 into either one of these original equations, and then you would have been able to solve for x by manipulating. You would get the same answer whether you put it into the first system, the second system, or this system here. You get the same answer. We're going to verify, just to review how to verify. And we'll do 2 verifications. In your homework, I'll get you to do 2 verifications. And then on your test, you're going to do 2 verifications. Remember, when you verify the original systems. So the first system, without manipulation, was x plus 4y equals 17. My second system was 2x minus y is equal to 7. X comes out, 3 goes in. Y comes out, 5 goes in. So 3 plus 4 times 5 equals 17. Or sorry, we're going to see if that equals 17. I'm going to erase that. Where's my mistake? There's got to be a mistake. X plus 4y equals 17. That would be 23, you guys. X is equal to 3. Do you see it? Yeah, so where is our mistake? Do you see? If the x... Oh, wait, but I should have plugged in a 3 here and a 3 here, right? So 17. Hold on. 17 minus 4. Okay, I'm not seeing it. Well, um, x is 5, y is 3. X is 5. Oh, you guys. You guys, do you see the mistake? X is 5, y is 3. That's right. See, as soon as it doesn't match, it's like I did something wrong. What did I do wrong? Look at how long it took me to figure that out. Okay, x is 5. That's the mistake. X comes out, 5 goes in, plus 4 times y, and y is 3. That will be our 17, because 5 plus 12, 5 plus 12 is 17. Bring that guy down. Left side equals right side, done. So when that wasn't balancing, I thought we made a mistake somewhere here. Like that's usually where you make the mistake, is somewhere up here. I just made the mistake transferring. Okay, let's see if we could do this one right from the beginning. Let's take this x out, put in 5. So 2 times 5 minus, take the y out, put in 3. 2 times 5 is 10 minus 3, which is 7. Left side equals right side. Story. Yes. Okay, flip your page. I do not like what they chose for class example number 2 because it deals with fractions, and we're not going to, we would do a different method if we had fractions. So I want you to cross out what they have for number 2, the class example, and I want you to write this for number 2. So first system, x minus 3y equals 6. Second system, 2x plus 3y equals 3. I want you to look at both systems. One of the systems I could solve for one of the variables in one move. That's the whole point of this. Which system could I solve? So Carly sees which one. Does anybody else see what it is? Ainsley sees. Okay. One of these, again, one of these systems, Angel, you see? What's that? It's the first system. You guys watch. It's this guy right here. It's x. I could solve for x in one move. Add 3y to both sides. That's all you have to do. Look for like a variable on its own, because in one move I could get what x is. So add 3y, add 3y. Now I have what x is. 6 plus 3y. When you solve the variable in one of the systems, you substitute it in the other system. So x is equal to this. So I'm going to look for an x in my other system, and it's right here. The x comes out, and I'm substituting what x is. 6 plus 3y. So it's going to be 2, 6 plus 3y, plus 3y equals 3. Now what you should see is we only have one variable, right? We're down to one variable. That's why we use substitution. So I've got 12 plus 6y plus 3y is equal to 3. Bring your like terms together. 12 plus 9y is equal to 3. Which variable am I solving for? Y, right? I've got a y, so I'm going to be solving for y. Get rid of that 12. 3 minus 12 is negative 9. And then get rid of the 9 in front of the y. What am I doing? Get rid of the 9. And what is y equal to? Yes. Y is equal to negative 1. You've just figured out what y is. You've just figured out what y is. What do you now need to figure out? What x is. Do you know where it goes? Into right here. Here's x. X is equal to 6 plus 3y. So we're going to take that y out, and we're going to put in negative 1. So x is equal to 6 plus 3 times negative 1. X is equal to 6 minus 3. X is equal to 3. This will be the last one that we'll verify. Let's see if we verify this correctly right off the bat. So, oh, actually, sorry, no, we won't verify this one. We'll verify the next one. It says check the solution using a graphing calculator. We won't do that. Okay, here's what I want you to write for class example 3. I don't like what they have again. So just cross out both of their systems for class example 3 and write these two. Look at both systems. In one of these systems, I could solve for one of the letters in one move. Raise your hand if you know if it's system 1 or if it's system 2. I need to know how many of you know which system it would be first of all. So I've got 2, 3, 4, 6, 7, 8, 9, 10, 11, 12. Juan, do you know? Not yet. Tristan? Okay, Kristen, you tell me which one. It's a second one. What is the move that I'm going to make in this system? Sorry? Nope, you're not going to do that. You're right, it's the second system, but you're not going to minus y. Anybody else want to tell me? Complete, what would it be? That's right. I want to get this guy by itself, so you got to get rid of that 5x. The move would be this. Add 5x, add 5x. Then what you've done is you've solved for y. That's what you need. You either need a y is equal to or an x is equal to. And once you have that, you look at the other system. I solved for y, you guys. So you go to the other system and you say, where is their y? It's right here. So this is going to come out, and what's going to go in for y is this, right? Y comes out, and that gets substituted in. This is why it's called substitution. Negative 3x minus 8 times y, 19 plus 5x equals 20. Here we're going to have larger numbers, so make sure you've got your calculator for this one. Get rid of your bracket. Negative 3x. Are you getting minus 152? Okay, minus 152. Plus, sorry, that would be minus 40x's. Is equal to 20. You'll always be able to put two like terms together at this stage, and the two like terms would be those x's. So it's negative 43x minus 152 is equal to 20. What you are solving for is x, right? That's the only variable that I have here. This is what you're solving for. I need to get this by itself. I'm going to get rid of that negative 152. I'm going to add 152 to both sides. Negative 43x is equal to 172. Okay, Erin, how do I get x by itself from here? That's right. It's negative 43 times x, so the opposite of times multiplying is division. Divide both sides by negative 43. And then you've isolated your x, and it's going to be 172. Yeah, divided by negative 43 would give you negative 4. So we know what x is. Now we got to figure out y. Where am I going to put this negative 4? Do you see where I'd put it? I need y is equal to. That's what I need to solve now, right? I need to solve for y. I need to know what y is equal to. You have to figure out where you're going to substitute that negative 4. And the easiest place is right here. X is negative 4. So take that out and put in negative 4, because then you have what y is equal to, right? So the least amount of work would be this one. 19 plus 5 times negative 4. Y is equal to anybody have what it is? 19. Yes, negative 1. So the two answers were x is equal to negative 4, y is equal to negative 1. If you plugged those into the original two systems, you would get the correct answer. Left side would equal right side. Let's look at the homework, and I'm going to set you up with some of these just to make sure you guys are good. So very few up here, but you're going to have a worksheet where you're going to practice this. Okay, and some of you were like not paying attention to this, so I worry a little bit. Okay, so 1 ABC, 2A, and I'm going to show you number 5, because number 5 we actually have to do in 2 steps. That's the only way we could get number 5 done. Okay, so let's talk about this. Look at system 1 and look at system 2. One system, it's already sort of solved for us. Do you see? It says y is equal to. That's the goal. We want one of our systems to say y is equal to or x is equal to. We don't have to do any work. They did it for us. Y is equal to this. That's my first system. They told me what y is equal to. I got to look for y in my second system, which is right there. That's going to come out, and x plus 2 is going to go in. So I'm going to write it for you, and then we'll go to b to make sure, and then you guys will solve it after. So 3x plus 4, the y comes out, and x plus 2 goes in. That is equal to 1. Then you're going to get rid of your brackets, and you're going to be solving for x. This system, actually, this one doesn't, oh, one of them I could do in 2 moves, and one I could do in 1 move. Do you know what it would be? At first I thought I could do this one in 1 move, but I can't because I got to subtract 5y and subtract 4, so that's technically 2 moves. This is the 1 move system. If you wanted to just do 1 move, to get x by itself, 1, what would I have to do? Add 2y. So let's do that. Plus 2y plus 2y. Now you have what x is. 10 plus 2y. That is going to get put into the other system. So see if you could figure by boxing and drawing your arrow, where would this 10 plus 2y go? So you say you just solve for x. This is what x is, and here's an x. It's going to go there. Let's look at C. Look at both. Raise your hand if you know which system. There's one you could do in 1 move. You could either get P is equal to or Q is equal to. Kalita, which one is it? It's the first system. What's the move? That's exactly what it is. I could get Q by itself in 1 move, and that move is this. Minus 4P, minus 4P. Okay. Then I have Q is equal to 0 minus 4P. Do I need that 0? No. So Q is equal to, and I'll get you in one, give me 1 second. Q is equal to negative 4P. You just solved for Q, right? Q is equal to this. So you go to this system and you're looking for a Q. That's going to come out and that's going to go in. Ainsley, what was your question? You got it. Let's look at number 5, because 5 has to actually be done in 2 moves. Or sorry, not number 5, number 2A. Did I write 2A down for homework? I think. See if you guys can figure out which one it is. Okay, do you see which system it is? Which is the easier one to deal with? Which is the easier one? Maria, which one? Number 2. Okay, so it's this guy here. You have to deal with it in two moves because of the following. We're going to solve for y. I need this guy by itself. Would you subtract the negative 1/2, or what would you do? Ainsley, what would you do? Yeah, if you're solving for y, we want this y to be positive. So what I would have done is I would have added y to both sides. And then I would have got, I'm going to change that 1/2 to 0.5 because that's easy to, it might look less messy like this. So then I got 0.5x is equal to 3 plus y. And this is what I want by itself. Y is now positive. I just have to get rid of that 3 by subtracting 3 from both sides. And then I have y by itself, and it is equal to 0.5x minus 3. That's what y is. So I look at the first system and I say, is there a y that I could take out and put in 0.5x minus 3? Because I just solved for y. So this will go right here. I'm going to give you about 10-15 minutes to finish those, and then I'll hand you the worksheet and tell you which questions I want you to do on the worksheet.